time we have seen about gypsum bonded investment material. Can you hear me?
Yes, ma'am.
Yes, ma'am.
So last time we have seen about gypsum bonded investment material. What is investment material? What is investing? And gypsum bonded investment material. Today we will be seeing about silica and phosphate bonded investment material. But before that, I will go through last time's part because many of you were not there. So, what is investment? So, investment is a procedure to make the mold for converting wax pattern into metal form. So, the material used for this procedure is investment material. So, investment material are of three types: gypsum bonded, silica bonded, and phosphate bonded. So, in investment material, basic composition is same for all. That is bonding agent, refractory agent, and additives. So, in gypsum bonded investment material, bonding agent is alpha hemihydrate, and refractory material is silica. So, and additives, in additives, there is sodium chloride or boric acid and coloring agent. So this is basic composition. Silica bonded, in silica bonded is also same composition. Just the bonding agent is different for silica and phosphate bonded investment material. So this is investment material. This is investment material. This is wax pattern, and this is screw attachment. So, and the base, I will go through all the part in brief. So, definition we have already seen. This is not for new people. So, requirement. In requirement, expansion is necessary for compensation of casting shrinkage. Strength is necessary because the investment material have to stand for high temperature. So strength is very important. Then it should not decompose at high temperature. It should be porous in nature. The particle size, again the particle size should be fine, very small, because the casting which we will get after the devesting should be of smooth surface. It is easy to divest. Manipulation should be easy. Setting time is adequate. Ideally, today's investment material, 9 to 12 minutes is setting time, and again it should be economical. Basic composition: refractory material, binder, and some modifiers. So, in a refractory material, silica. It has two functions. That is, it should withstand high temperature, and it should regulate thermal expansion. For silica is binding material, refractory material. It should have two functions. That is, it should withstand and high temperature, and it regulates thermal expansion. So, binder. The binder for gypsum bonded is calcium sulfate hemihydrate, and for phosphate bonded, ammonium phosphate. Before, phosphoric acid was binder, but nowadays it is replaced by ammonium phosphate. And in silica bonded, silica gel is binder. So modifier, again modifier, in modifier reducing agent is there, and modifying chemicals, that is boric acid and sodium chloride. So the modifying chemicals have two functions. It regulates the setting time, and it regulates the setting expansion. So these are the main functions of modifying agent. And the coloring matter. So types of investment material: gypsum bonded, phosphate bonded, silica bonded. So basically gypsum bonded is used for noble metal, that is conventional gold alloy. Phosphate and silica, silicate bonded investment material withstand high temperature, and therefore it is used for base metal alloys. So again, Gypsum bonded investment material. These are classified into three types: type 1, 2, and 3. Type 1 and 2 is used for single crown, inlays, onlays, and type 3 is used for uh, CPD, cast partial denture. So again, the composition, the refractory material, binder, and modifying agent. These are the percentage of particular product. So in refractory material, silica, it provides high temperature thermal shock resistance. The function already we have seen of refractory material, regulation of thermal expansion and withstand high temperature. So effect of temporary temperature on refractory material. So basically the refractory material are of different types, that is crystalline, quartz, and tridymite. So the transition, it has displacive transition temperature. So this temperature helps in conversion of alpha form into the beta form. Here you can see the conversion of alpha form into the beta form, and the particular for the particular refractory material, the temperature varies. So it is 220 for crystallite, then for tridymite it is again 105, it converts into middle tridymite, and at 160 into beta form. So again alpha form quartz converts at 570 degree into beta form. So this is displacive temperature, transition temperature. Again the binder. So the binder is alpha hemihydrate. So effect of temperature on binder, that is 200 to 400 degrees Celsius. It is again above 400 degrees, above 700 degrees Celsius. There is formation of reducing agent, and the metal for the casting you get is of blackish in there will be blackish discoloration for the on the casting. So this is again for above 700 degrees Celsius you cannot use gypsum bonded investment material. So this is only useful in case of noble metal, and for the base metal, that is where the requirement of high temperature is needed. So there silica or phosphate bonded can be used. So again the modifiers, reducing agent, additives, and coloring agent. So already this is. So investment procedure, again in investment procedure, hand mixing and machine mixing or vacuum form mixing. In hand mixing the drawback is incorporation of air. So for this purpose you need vibrator. But in a vacuum mixing there will be no incorporation of air particles. So again the setting reaction is same that of gypsum product. Calcium sulfate hemihydrate regains the water, then it converts into calcium sulfate dihydrate, and the reaction is exothermic. So the setting time, again the setting time I already told you so, that it is 9 to 18 minutes for modern investment material, but it should not be less than 5 minutes and not more than 25 minutes. So factor controlling the setting time, again the manufacturing process. In manufacturing process, the two important factor. Yes, Shubham, what is your problem? Yes, Shubham.
No, no, कुछ
Okay, no problem. Then in manufacturing process, there is two important factor you should remember, that the additives which is added by the manufacturer, that is modifying agent as boric acid or sodium chloride. The content of boric acid and sodium chloride, it helps in regulating setting time. So again it is depend on the manufacturer, that how much accelerator or retarder to be added. So again this controls the setting time. And again the composition of calcium sulfate dihydrate, if the calcium sulfate dihydrate helps in fastening the reaction because it acts as a nuclei of crystallization. So this is one of the mm, this is again in the manufacturer's hand, and this is one of the factors that regulates the setting time. So mixing time and rate, again the longer mixing and vigorous spatulation helps in fastening the reaction, because it helps in even distribution of calcium sulfate dihydrate into the product. So it will fasten the reaction. Then water powder ratio, again the more the water, longer the setting time. Temperature, so the temperature of water again helps in regulating the setting time. Higher the temperature, longer the setting time. At 100 degrees Celsius, there will be no reaction. Then the modifier, again, I told you already this modifier, accelerator and retarder. So, okay. Setting expansion. So there are three type of setting expansion: normal, hygroscopic, and thermal expansion. In normal expansion, the normal setting reaction takes place. The nuclear crystallization start expanding with a deposition of a fibrous structure on it, that is intermeshing of crystal, fibrous crystal. So this is normal setting time. In normal setting time, greater setting expansion with silica and gypsum. And this is different from the gypsum product, because there will be a silica particle in between. So this silica particle helps in expansion. So here, in case of investment material, it is more expansion takes place than that of a normal gypsum product. So according to ADA specification number 2, for type 1 investment permits maximum setting expansion of 0.6%, and for modern investment it is 0.4%. So factor controlling the setting expansion: water powder ratio, spatulation, and modifier. So again the water powder ratio, more the water, there will be more expansion. And spatulation, again the spatulation is more, uh, the expansion will be more. Modifiers helps in a expansion of material. So this is this setting expansion helps in compensation of a casting shrinkage. So hygroscopic setting expansion, it occurs when gypsum product is allowed to set under the water. So here it is 6 or more times than that of a normal setting expansion. So according to ADA specification number 2, for type 2 investment requires minimal setting expansion in water is 1.2%, and the maximum it is 2.2%. So factor controlling the hygroscopic setting expansion, here again the magnitude is directly proportional to the silica content. Then the particle size also affect the setting expansion, and in case of alpha hemihydrate it is more than that of the beta hemihydrate. Then effect of water powder ratio. Okay, the water powder ratio also helps in controlling the hygroscopic expansion. Then effect of amount of water added. So effect of time of immersion. So if earlier the immersion into the water, the more will be the expansion. And again effect of spatulation, more vigorous spatulation helps in setting expansion. Effect of confinement, the wax pattern and the flask used for the investment, that confines the material, so it controls the setting expansion. Then shelf life of the investment material, if it is expire or for the expired product it is less setting expansion. Then thermal expansion, it is directly related to the amount and type of silica. So I already told you the silica is refractory material, and refractory material has two functions. One is regulation of the thermal expansion, and the other is withstanding high temperature. So again, the amount and type of the silica present, because silica is of different type, that is cristabalite, tridymite, and quartz. So for a particular product, there will be a different type of the setting expansion. So again, it is depend on the type and amount. So ADA specification number 2 requires that thermal expansion for type 1 investment must not be less than 1%. but it should not be greater than again 1.6%. And for type 2, it should be between 0 to 0.6% at 500 degrees Celsius. Then strength. So strength is again very important because it should withstand a high temperature. So it requires that compressive strength of inlay investment should not be less than 2.4 MPa when tested 2 hours after the setting. So factor affecting the strength of the investment material is type of gypsum binder, amount of gypsum binder, and more the binding agent, more will be the strength. So use of chemical modifiers. So chemical modifiers again affects the strength. It weakens the product. But chemical modifier helps in regulation of setting expansion and the setting time. So amount of mixing water. So more the water, less will be the strength. And cooling of the investment. Again, sudden cooling. If you there if you cool the investment product suddenly, there will be the crack. So again, it is the factor affecting the strength. So high temperature investment. So high temperature investment, there is silicate bonded and phosphate bonded. And the high temperature investment are basically used for the base metal alloy. So here the base metal alloy is used for the metal ceramic restoration, and the cast partial denture have high melting point. So they are cast in molds of 850 to 1100 degrees Celsius. To withstand high temperature, the molds require different type of binders such as a silicate and phosphate. So here the phosphate bonded material, these are the common brands. So it is supplied into two components, the powder and collided silica. So composition is filler. So filler is silica in the form of cristobalite, quartz, or the mixture of two, and it provides high temperature thermal shock resistance and thermal expansion. So binder. The binder is monoammonium phosphate and magnesium oxide. Originally, the phosphoric acid was used, but nowadays it is replaced by monoamino phosphate. So carbon, it clean casting and facilitate devesting. So devesting is a procedure in which the investment material is broken down, and whatever the casting is removed from the investment material. Then liquid, in liquid water and silica. So investing procedure, hand mixing again and the vacuum mixing. Setting reaction, here the ammonium diacid phosphate is used in greater amount than necessary for the setting reaction. So ammonium diacid phosphate plus magnesium oxide plus water gives you a final product. So setting and thermal expansion. So here colloidal silica in aqueous suspension increases the setting and thermal expansion. And when it mixed with water, it shows shrinkage between 200 to 400 degrees Celsius. So again, the setting time, the warmer the mix, faster the setting time. These are the factor affecting. Increase mixing time, and mixing efficiency results in faster set. Same with the gypsum product. Increase mixing time and mixing efficiency, faster the set. Then the liquid, again the water powder, liquid powder ratio. So here the liquid powder ratio also helps in regulation of a setting time. So more the liquid, there will be delay in the setting. Advantages: high grain and fired strength. It has high grain and fired strength because it is used for the base metal alloy. So it have to withstand high temperature. So again, the strength is very important when silica and phosphate bonded investment material are there. Then high setting and thermal expansion. They can withstand temperature up to 1000 degrees Celsius for short period of time. Useful for fabricating porcelain veneers. So disadvantage is mold breakdown, and rougher surface of casting when used for the alloys with a casting temperature higher than 1375 degrees Celsius. So it is up to 1100 degrees Celsius, it is fine, but above that the casting you get is a rougher surface. So this is one of the disadvantage. It is difficult to divest, then less porous mold is produced when more of the silica liquid is used to achieve the higher expansion. So silica liquid is help in achieving the expansion. But if you use in more amount, it will produce a less porous mold. So again, this is one of the disadvantage. So ethyl silicate bonded investment material. So here it is supplied as two bottles of special liquid instead of water. So properly diluted water, soluble silicate solution, and properly diluted acid solution such as hydrochloric acid, and powder consists of refractory material and magnesium oxide. So this is the setting reaction, and disadvantage, it contains inflammable products. So hence sodium silicate is preferred. Then investing procedure. Here powder plus hydrolyzed ethyl silicate liquid vibrated into the investing ring. It is mixed and vibrated into the investing ring. So heavier particle settles down, and the liquid or powder liquid powder ratio. When the heavier particle settles down, there will be the liquid which comes out of the that product, and there will be setting shrinkage. So advantages of ability to withstand higher temperature than that of the phosphate bonded. The silicate bonded investment material have ability to withstand more temperature, so more permeable, and divesting is easier compared to the phosphate bonded material. The disadvantage of this material is more fragile, complicated, and time consuming procedure, and prone to cracking during the burnout and firing process. So, so to summarize, the topic is the investment material are three types: gypsum, silicate, and phosphate bonded investment material. So, so these are the three types of the investment material. So gypsum bonded investment material is used for uh, gold alloy, and phosphate and silicate bonded material is used for, it is used for base metal alloy. So this is the video showing investing procedure. Basic vacuum mixing machine. This is casting machine. So this is about investment procedure.